Question is in regards to heaving. You explained about putting footings in for shrinkage. Is there any footings that you know of that can go in for heaving?
Well, Dominic and I will probably still argue about this. That's more problematic. The old idea was it used to appear that as well, but engineers have two alternative views. If they tie the pier to the footing, that can have some tie-down effect. Typically, they don't tend to do that. Peter Mitchell, who's one of the preeminent engineers in Australian footing performance, his theory is that you design piers for downward movement, and if you're concerned about upward movement because of potential tree removal or something like that, you should design the extra stiffness into the footing system or slab to cope with the uplift. And he's one of the preeminent experts. Well, instead of all footing systems, depending on the reactivity of the clay, strip footings and slabs are designed to be stiffer for more highly reactive clays. Like the western suburbs, the footings are deeper, more reinforcing, so they've actually got a higher degree of stiffness, so that when movement occurs, they're better able to resist it and deflect it over a greater distance. That's the extra stiffness. So in that situation where you're worried about heave, you would just probably increase we give them what was called an estimated ground surface movement, which is expected movement you're going to get. I would generally increase it by 1.5 times, or maybe 2 times if I was concerned about heave. So the other solution is to tie down the footing system with piers, but I mean, I'm not a big fan of that. But you'll get, unfortunately, engineers who disagree as well. So yeah.
The problem is that the Australian standard, the first Australian standard, was devised for using the idea that slabs would, and bear in mind that when the first Australian standard came out, slabs weren't very popular. So it was the beginning of the slab period, should we say. And the theory was based on the slab achieving a mound shape rather than an edge curl that you would get an edge heave. As a result, all slabs are still being designed for mound shape, which only really happens in Melbourne during drought. So when we have heave, the slabs are less capable of withstanding or spreading the load. The angle of deflection, as it's called, in a mound is more gentle than when it heaves. When it heaves, the edge of the slab curls up. And the other thing we're finding is that when the mound shape is developed during the drought, all the damage is in the outside walls. When we have heave, nearly all the damage is on the inside walls. I won't go into all the details why that is, but it is.
David and Dominic, just wondering why you just said slabs are relatively new in the construction of dwellings. Why on clay soils do they continue to persist with building slabs when screw piles and individual stumps seem to be a lot better?
You've got to remember how old Dominic is. He said when he earlier on, so he's talking a long time ago, right? So
I'm giving you a longer history.
Yep. Slabs now are the preferred footing system across most areas, especially in the western suburbs. Dominic and I will probably disagree about this, but the performance of slabs has actually been okay even during the drought. I mean, with 3.5% failures, you'd argue that that's a pretty good success rate in terms of footing system. And Dominic probably would disagree slightly with that. So from my opinion, I reckon they're doing okay. Installing the screw piles under all slabs to cope with all adverse potential soil problems, as I said before, the cost impost on the total building public of Australia would be enormous to protect a small number of people who are suffering.
You're saying $2,000 for maybe half a house?
Yeah, but for a whole house, you'd be talking probably $50,000. So, well, again, and I don't disagree that if you're going to, and my house has got piers on it because I can plant whatever I want around it, and I don't disagree. If you understand the concept that you can have whatever you like if you just spend a bit more on the foundation. I struggle every single day trying to convince builders to not cut the tree down and to put piers in for a couple of thousand because they just think it's easier to do it. Do you know what I mean? And Well, it would come down, but it's just, I can tell you right now, it's not going to happen. As I said, what we've tried to do is at least we've got the way we have got it incorporated, at least we've got to consider these things, and it's much more widespread now, adopting piers near trees than it was. So at least that's a start. But I can't see the day coming when they're going to adopt deep piered footings underneath the whole thing.
One more question, sorry. The 28% is vector, say, soil moisture levels in clay soils. When was that figure originally?
Oh no, that's just a measured moisture. It's just a really nice number because it means different things in different. Dominic did a great example at a conference just like this, where he produced three soil samples. One was a clay sand, one was full basaltic clay, and one was a sandy clay, right? The clay sand, you couldn't hold in your hand, it just flowed out, right? The sandy clay you could mould quite easily. The basaltic clay you could just indent with your thumbnail. And everyone was asked to say what the moisture content was, and everyone said, "Oh, the clay sand's really, really wet. That's the wettest. The sandy clay's next, and the basaltic clay's way drier." In actual fact, the trick is they're all 28%. It's just an example to show you that clays or different soils, the same moisture content in different soils is completely different. And we get so many engineers ringing up going, "Just do me a moisture content," and you know that they have no understanding of how to interpret those moisture contents. No, they don't. No, that's just my number. It's just my number. Yeah. Yeah, probably have. Yeah, you definitely have. Yeah.
The problem is that they shouldn't ask for moisture content. They should ask for the moisture state. And the moisture state is a comparison of the moisture against plastic limit. At least we can standardise it, but we can't standardise it because it's comparing apples with cauliflowers and carrots. So that's why it's not a good idea just to ask for moisture contents. It doesn't tell you anything. Unless, of course, they've done other testing, such as Atterberg limits, and that they tell you where you're at. But just moisture contents by themselves don't tell you much at all.
Well, working on it. Well, I haven't started yet.
One of the solutions that seems to get recommended fairly often is for neighbours' trees and getting footings in to try and protect those trees. And the recommendation is to put in board piers and have a capping beam. But most of the engineers suggest they've got to bed the capping beam in 500mm into the soil anyway, which means those tree roots are going to be lost. Is it possible to have a capping beam set above grade? Yep.
Well, the problem with having an above ground system, we often would recommend that for typically for front fences and sort of thing. When you don't want to disturb the tree roots, you'll actually have a galvanised steel lintel above ground. You can build brickwork and that sort of thing. The problem with incorporating it into a footing system for a structure is you need to have the footing system integral with itself to perform the required stiffness level. So having an above ground system, it would work if they could have the floor level high enough so that you could actually deflect the footing up and then back down again. If that's the case, the problem with town planning requirements at the moment, they're governed by heights, so they can't really come above ground level because they'll sacrifice their heights. That would be the only problem that I'd see to make it integral with the whole footing system. You need to have it. Yeah, well, it always costs more. Yeah. Oh. Yep. Sorry.
Just can you use that structural soil you were mentioning about for above grade driveways? I find that it's been a problem. Do you understand what I mean by above grade driveways? Yeah. I've found that like the common solution is to put like a washed aggregate down and then people lay like a bitumen on top or something like that, but I find that they fall apart pretty quick. Do any of you guys have any better solutions?
Yeah, well, I've not really come across structural soil before for that situation.
There are better qualified people.
I don't know whether it's available over here, but there's something called cell web in the UK, which is like originally came from the military, needing to get across deserts quickly, and they can just roll out. It's like a sort of honeycomb material that you then put the aggregate in, and that's much more stable than just piling up aggregate. resist the lateral forces and so on. So, and they typically, call it the no-dig solution to installing a driveway. There are some issues with it, but that would probably be certainly better than just piling aggregate above the ground. Yeah.
We do have that.
It's
I do. Yeah. Okay. Yeah.
It's called geogrid.
Oh, there you go.
Martin, do you have something on that?
Yeah, I've also had experience in using those load spreading cells, so that's one example with the no-dig construction. The other thing I've been involved with is that space soil that I showed you before, which is the soil used in South Australia from waste products from the reservoirs. Had quite a few instances where we've installed permeable paving on space soil around old river red gums and stuff, so that's an option to consider if you had access to that sort of soil in Victoria.
About footings before. So if you're doing a pier and say beam and you're over top of your root, does that mean that the rest of your footing has to be at that height? So if you're putting in a slab, then it all has to come up to the height of your above grade portion of your footing, so that the whole thing can move at once.
Yeah, the idea of a footing system is to maintain that integrity around with a strip footing, you've got some potential to step it up a slope, but with a slab, the reason the slab works as a raft is because it's all on the same plane. So that, if you're trying to lift it higher, which is what you want to do for tree roots, you would actually need to bring the floor level up. Bring the whole floor level up, yeah.
Can I pick you up on that? The reason one of the reasons we're having a lot of problems with builders at the moment is that they still believe that the slab acts as a raft, and a raft goes up and down evenly. Now, 98% of our slabs are waffle type slabs. I don't know if you know what that means, but they're very closely gridded slabs, and they're called waffle slabs. And somehow at the beginning, someone got the idea that because they were so closely gridded, that they would act as a raft on water. As a result, builders began to believe that they could put these slabs on fill, no matter what sort of fill it was. As a result, we had a lot of failures because of those waffles on fill. And they're the only, bearing capacity failures that I've ever examined. I mean, no other than maybe an occasional strip footing.
Are the signs more severe in that particular type of failure in the building? The signs of distress, are they more severe?
No.
They're different. It is
different. Yeah, typically the drying distress tends to be worse because the heaving tends to occur in more modern slabs, which have got a better deflecting capability. So yeah, the level of distress seems to be a bit less because it's deflected over a greater distance. Yeah.
Gentlemen, just wanted to ask the question, when we're looking at roots that are going close to footings, etc., the science I think before was looking at DNA, so we were trying to work out which tree it was. Is there some new science that's going through which is looking at the absorption rate of the roots into the soil, or absorbing the moisture out of the soil?
No, I'm not sure. From an arboricultural point of view, not from a geotechnical point of view.
We wouldn't attempt anything like that.
I'd be really interested in finding out about it.
Always consult an arborist and let them do the testing.
The arborists on the panel, have we heard of any latest testing or research into those sort of things? I have vaguely heard recently that younger trees used to be thought that bigger trees would take more moisture out of the ground, but it's gone right out of now. But I believe that younger trees, because they're growing so actively, and especially certain types of trees that have huge bulbs come up, something yellow on there, moisture is a lot of mature trees.
Yeah, look, there's a couple of comments there. In relation to your question, you can use various ways of tracking the water uptake, ranging from simple techniques that we've even tried with Roger Greenwood years ago, using water-soluble dyes. But they also have radioisotopes that they can track. But by and large, the technology is way more expensive than the... so it's pretty much in the theory. So DNA is still probably the best way of tracking which individual root system that you're looking at. And in relation to water uptake, it's quite right that young trees take up more water per, if you like, cubic centimetre of tree, but it doesn't mean they're taking up more water overall. So you've actually got to look at the size of the trees, and you've got to work out how much they're taking up. Relatively speaking, a young actively growing tree may take up more water than a mature tree of the same species, but the amount of water will normally be bigger for the larger tree under the right conditions. And the other thing to make comment there is that a lot of people sort of think that trees just take up water and there's no regulation, and so that they'll just keep sucking the water out. But very often species will reach a point where they actually close their stomata when the water becomes limiting, in which case they're not adding further to the drying of the soil, they actually close up. But trees that keep their stomata open, in other words, the profligate water users, if you like, they'll just keep sucking the water out, and they'll suck it out till things are dry and they die. And so they're the really problematic ones.
And I also know that Don Cameron at UniSA has done a lot of research into the soil suction of different tree species. On leaves. Yeah, so he's looked at the soil suction of different tree species such as eucalypts and can establish that sort of information.
Can I tell you an interesting connection between trees and clays? The leaf area of a tree is a good the total leaf area of a tree is a good indicator as to how much water they use. Would I be right? Okay. Well, the leaf area of clays is also has the same rule, because the more surface area you have in the clays, particles, the more capacity they have for drawing water in. And just to give you some idea, 2 grams of Montmorillonite clay, if all the particles were put down on the floor and created a jigsaw effect, joined them all up, would occupy 100 square metres. 2 grams, 100 square metres. And that's the reason why some clays are have much more suction than others.
Yeah, well, look, let's confound this even further, because if 2 grams of Montmorillonite clay do 100 square metres, 2 grams of organic matter do a square kilometre of surface area. Now, this is so important, but it's a two-way sword, a double-edged sword. Basically, we heard the figures to say, okay, here are these clays, and there's sand, silt, and clay in the soil. But we heard earlier this morning that no, hang on a minute, 5% of this soil is organic matter, and in these clay soils, it's often 10% by weight, right? So often naturally kilo and stuff like that, we had clays with 10% organic matter. And so the capacity of these clays to hold water because of this organic matter has this massive increased surface area and therefore massive increased water holding capacity. But it's of course a positive on it as well, because the real worry is this reactivity, the shrinking and the swelling. And we saw that soil in the tailings dam and foot-wide cracks developing, monster reactivity, no organic matter. Once you've got organic matter in that soil, you've got a totally changed situation, because that organic matter is acting as a sponge, certainly to absorb water, but it's also acting as a buffer to sort of bring that reactivity right down. So a lot of that reactivity is taken up by the organic matter. So the physical dynamics and structure of these soils, these clay soils with organic matter, is completely different. Now, we don't have simple equations for that. It's sort of pretty complicated. But again, in terms of wetting, drying, trees, no trees, it's really a much more buffered system. I think at the end of the day, I come to the point, yeah, you've got piers, and so you're anchoring the thing, but you've got a pretty dynamic soup that you're trying to work with. it's got a whole lot of different dimensions than just that simple, sort of clay physics. It's also got this whole organic matter variable built in.
I guess just to build on what's been said, I mean, species differ quite widely in terms of their capacity to extract water from the soil. So some species might go down to, say, a water potential of -1 or -1.5 megapascals. Other sclerophyllous species, such as some of your eucalypts, might be able to extract water down to -5 or 6 megapascals quite easily. So depending on the vegetation that you've got above ground, as well as the leaf area of that vegetation, will impact on how much they're able to dry the soil out. The very drought intolerant, or the ones that lose turgor at quite high water potentials, probably aren't able to really seriously dry a clay soil down, whereas other species may be able to do that and then act on the volume of that clay. So yes, it can get pretty complicated.
Just going back to with the footings, putting in piers, and the cost you think overall is too great for the average Australian house that doesn't have, like the small percentage that doesn't have a problem. Greg said earlier with construction, he increased the rigidity of the footing, and you mentioned yourself like that if they could stiffen it more. Is that not a more cost-effective solution and something that could should be considered more, or is it sort of an equal sort of cost to putting extra piers in, or?
My view on this is based on the number of investigations we've done on those very types of footing systems, where there's and Dominic helped put a code of practice together that talks about increasing stiffness in regard to drying. I've not seen that work. We've going back even into the late 80s. We were looking at houses up in Horsham that had edge beams that were 1,200 millimetres deep with 25 millimetre reinforcing bar to try and make them so stiff, and they still suffered deflections because of tree drying sediments. So I personally think, and different people have different views on this because some engineers still design extra stiffness, but we've looked at a lot of buildings that have had footings and slabs designed with extra stiffness to take account of drying sediments, and they've failed. That's just personal experience.
Deep footings aren't the answer to drying affected trees, because in my experience, tree roots actually grow towards deep footings. They grow towards a shady part of the house, or they grow towards that disturbed part of the soil alongside the footing, and the roots we find that reach the footing will grow laterally along the footing and even around corners, and in one case surrounded the house.
You mean deep continuous footings?
In deep continuous footings. And deep continuous footings, strip footings, were given up a long time ago to cope with that. So that doesn't work. It's better to have piers.
The other reason we adopt piers with a shallow footing system as distinct from a deeper footing system is we've seen a lot of problems where they've put deep continuous footings in for trees 2.5 metres deep that does horrendous damage to the root system just because the builder wants to do it because it's easier. They've solved the vertical problem, so you don't get any settlement vertically, but what they've done is created a cut-off wall effectively, so the moisture content on one side, especially the uphill side, tends to still get moisture getting trapped against it, and the moisture on the downhill side drains away, so the footing actually moves laterally and it shears on the damp coarse layer. Whereas if you use a pier and beam system, the moisture content can equalise inside and outside the footing, and you've got the added advantage. If it's a shallow footing system, it doesn't damage the tree roots as much, so that's another problem we've had. It's a significant problem because the ones that move laterally are really hard to fix. So.
I've got a question for you. If I can use this probably. How often are you coming across tree root conflicts with pipes as a result of poor backfill and poor connectivity by the installers? And what's the furthest you've seen a root travel along a poorly backfilled trench?
About 40% of our works in PVC drains that have been laid after 1979, so it's significant.
Why 79?
Why
joints when they started using PVC, I think it was. There's just so much trouble with tree roots getting into PVC because the joints weren't glued properly. So a join will pull a little bit, the tree roots just dive straight in. We see it all day, every day. And cameras have given us the ability to be able to identify exactly where the cause is. Cameras are our eyes. They allow us to know what to do to fix a problem.
My question is to David. Given what Dr. Eli mentioned about trying to keep stormwater local, trying to maintain the hydrology of the soil, do you see that might have a negative impact on the shrinkage and swelling of soil, especially highly reactive clays, when in the current practice stormwater is taken off-site and through the stormwater network and away from local areas? If we were to start to encourage people to keep or control their stormwater and keep it local by integrating it into their own backyard, through a veggie patch or through a garden or through a water-sensitive urban design swale or whatever it might be, could that have negative impacts?
Yeah, it can on reactive clays if it's a deep non-cohesive soil profile, sand or silt, it wouldn't be problematic. But if it's a particularly highly reactive clay, it's got some problems for causing edge heave to occur. There's been a pretty big push to try and harvest and reuse urban stormwater on site. And as I said, there's areas where it works really, really well. But what they haven't considered, and I did a job for a client recently who's a UK engineer who's out working on this very issue, is they hadn't considered that. They hadn't considered the geotechnical aspects of adding water to the soil. I guess there'd be ways around it if you could try and do it on larger lot sizes to keep it away from footing systems. That would be an advantage. And that also brings me to the point that a large architectural inspection company, it's taken us 25 years to convince them that the cracking in houses is not caused by bearing capacity, it's caused by soil dryness. So their knee-jerk response was, let's add water to it. Now, if you can tell me how much to put on, what application rate, what happens when you stop, and how do you stop attracting tree roots to the very clay that you don't want, whereas if you used your system and created an environment away from the trees, away from the building that you could actually attract the tree roots to, that would be an advantage of the system.
But just as we had road systems that drain the water away from the road and onto a verge and feed the tree, why don't we use some of the systems that are developed in other countries where the storm water from houses goes into an area, a soakage area, where a tree could be planted?
One last question.
Sorry, probably broke it. David, just going back to some of your footing stuff you spoke about in your talk, I came across a property about 18 months ago I did a report on where there was a small to medium-sized oak in the front yard. The house had significant cracking on the front half of the house, which was consistent with where the tree was. I then got given 2 copies of soil reports, which were quite ambiguous and contradicted each other. And my, I suppose, little knowledge in housing engineering came up with the theory that looking at the plans, they'd put piers in on only the front sort of section of the house, that the front was moving more than the back, but it wasn't enough information in the soil reports to sort of suggest why that's so, or whether the tree was at fault. Could you elaborate on whether or not sort of using piers throughout the whole house would possibly solve that issue or not?
Yeah, I mean, that sounds like an unusual one. If the piers were put in correctly at the front of the house, that should have taken account of any tree drying settlements, maybe it was heaving. And this goes back to getting decent geotechnical advice to start with. They shouldn't be ambiguous, and they should be conclusive as to what the outcome is. But if you're getting, sometimes it's a section of the building that's not moving that shows the cracking, and it could be heaving at the back of the house and not drying at the front of the house. And that would be an advantage if you had piers that were tied in. Yeah, maybe that would have stopped it. But if the piers were installed correctly at the front of the house, that should have addressed the tree drying issue. Yeah, but did they do a soil test at the back to see if the moisture content was high? So there could have been a heave at the back. So yeah, that's what I was saying before, going back to what Michael was getting. They're getting lots and lots of reports just based on walkthroughs and not enough evidence to be able to make a conclusive judgment as to what it is. And that we need to standardise what's acceptable as a geotechnical distress report, so you can be confident that if it says it's a leaking pipe or the tree or whatever, that you can be confident that it's not good enough just to base it on walkthrough evidence. Yeah. Yeah, I heard that too, yeah. Yeah, well, yeah, and I've been approached by a couple of barristers to do the same thing for court documents as well, and they need to have a standardised. The problem's going to be, and Dominic and I have both put a lot of work into standardising the codes of practice for doing soil testing in Melbourne over the past probably 20 years. That's helped quite significantly lift the standard of soil testing in Melbourne. The problem is the larger companies doing the large project work don't want to know, and they don't want to be bound by those codes of practice because it will influence their business. They only want to recommend what their client wants to recommend. So there'll be still people who will be refused to be bound by those codes of practice, and it's always going to be the case. You just get to know which ones are which. Yeah.
Just one last word. Just the other day I was at a house where a lady had made a claim against the insurance company about our house had heaved, and the insurance company was about to underpin it. Think about that.
That's all the time.